So let's do another FSM timing diagram example where we're given a timing diagram and we need to produce a state diagram. So we can also, instead of writing out state variables, we can just give states some names. So here we have states A, B, and C. So we have one input X and one output Z. And here you can see that Z is making transitions that are in between the clock edges, so in between the states, and it sort of is following along with what X is doing. So that means Z is a mealy output. Alright, so let's go ahead and draw our legend. We have the state. We don't have any more outputs, so we don't have anything down here. We have the input X and the mealy output Z. Alright, so it looks like our clear signal starts us in state B. So here's state B. I'm going to put our asynchronous clear right here. And we're going to transition from B to B when X is a 0, and our output Z is going to be a 1 in that case. So we're going to have a 0, 1. Then we have B to B again, should be the same, which it is. Now we have a B to C. B to C is going to happen when X1, I should call this X1 because that's how it's labeled in the diagram, when X1 is a 1 and Z is a 0. Then we're going to go from C to A when X1 is a 1 and Z, you always want to take the previous state, so Z is a 0. X1 is a 1 and Z is a 0. A to A. A to A is when X1 is a 1 and Z is a 1, sorry. A to B. A to B is when X is 0 and Z is 0. So again, remember, I'm looking at what happens right before the clock edge. So Z is 0 before the clock edge. B to C we already have, but let's just see. We're still missing B to C. Okay, we have both outputs of the B state already, so we're good there. We still need another output of the C state, so let's look at that transition. So we already have the C to A state. Well, actually, we have one of the C to A states. So let's see what this does. C to A happens now when X is 0 and when Z is a 0. So what we could actually do, since whether X is a 0 or a 1, it'll always go to A, we could actually rewrite that transition if we wanted to cross these out. It could be a don't care 0 because we don't care what X is and the output Z is always 0 when we transition. Alright, and so we check that we've completed it because we have an X equals 0 transition and an X equals 1 transition coming out of B. We have both transitions coming out of C and both transitions coming out of A. So we are complete. Okay, so now let's think about going the other direction where you're given a state diagram and you need to complete its timing diagram. Alright, so in this state diagram we notice that we have 3 states. We have an asynchronous active low clear that brings us to state A. We have an output Z, which is a mealy output because we've listed it on the transition here. It depends on both the inputs and the state. And we have 2 inputs, X1 and X2. And you can see that X1 and X2 aren't always listed for each transition, which means in this case X2 not is the only thing that matters and X1 is basically a don't care. Alright, so when doing these timing diagrams, it actually first helps to come up with equations for your mealy outputs based on your inputs so you know how to fill out the timing diagram. So when you're in state A, let's look at the transitions leaving state A. We have this one that goes to B, and we have this one that goes to C. So if you look at these transitions, you see that Z is always the opposite of X2. So here X2 is a 1 and Z is a 0. Here X2 is a 0, Z is a 1. So in state A, you're going to have your Mealy output Z equal to X2 naught. Alright, now let's look at the B state. In the B state, we have the output Z being 0 no matter what. So we're going to say from that state Z is going to equal 0. In C, let's look at our two output transitions. We have this one here, X2 naught, Z naught, and then we have X2, Z naught. So again, our output Z is going to be 0 no matter what. Okay, so now we can go along and fill out our timing diagram. The clear signal is active, low, so here we're going to start in state A. And in state A, we've already determined that Z is whatever X2 isn't. So X2 is a 1, and so Z is going to be a 0. Okay, so now we are going to transition to what state? Well, we have the condition where X1 is 0 and X2 is a 1. So we're in state A. X2 is a 1, so that satisfies this transition right here. So we're going to transition to state C. Now that we're in state C, our output Z is going to be 0. And now we need to figure out where we're going to go next. So here we're in state C and we have a 0, 0. So in state C, X2 is a 0 and X1 is a 0. Here we're only depending on X2, so we take the X2 is 0 path and we're going to go to state A. And in state A, Z is not X2, so X2 is low, so it's high here, and then it's low. Okay, we're in state A and we have the 1, 1. So in state A, now we want the X2 again is a 1, so we go to state C again. In state C, Z is 0. Now we have the 1, 1 case for state C. If X2 is a 1, we're going to stay in state C. So in state C, Z is a 0. We have the 1, 1 case again. So we're going to stay in state C again. And in state C, Z is a 0. Now we have the 0, 0 case. So we're going to transition back to A. In state A, Z is the opposite of X2. X2 is a 0, so Z is a 1. In state A, we have the 0, 0 condition. So X2 is 0. We're going to transition to B. In state B, Z is a 0. And now we are in state B and we have the 0, 1 condition. So in state B, X1 is what is mattering. So X1 is a 0. We're going to transition now back to A. In state A, we have Z is the opposite of X2. X2 is a 1. So Z is a 0. And we have finished the timing diagram.